morning students, this is Junita Mukherjee from XII Public School once again, and I am going to give you the topic, discuss about the topic magnetic field of a solenoid in chapter number moving charges and magnetism of class 12 physics. So a long coil of wire consisting closely packed is called a solenoid. We know it very well as we have read in 10th standard. So those magnetic field resembles that of a bar magnet of south S and the north N pole as shown in the figure. So this is a solenoid rounding, the coils are there. Okay, so there is a long coil of wire consisting closed packed loop which is forming a solenoid here. This is the magnetic field going on round here, and this is the PQRS we have taken as here the rectangular closed part we are considering. So inside the solenoid, magnetic field is uniform parallel to the solenoid axis. Outside the solenoid, magnetic field is assumed to be zero. So considering an air coiled solenoid having closed packed coils with I is current and N is the number of the turns per unit length and B is the magnetic field inside the solenoid. So applying Ampere's circular law to determine the magnetic field B inside the solenoid, we choose the rectangular closed path PQRS where PQ is equal to L. We are taking this as L, and the line integral B over closed path will be PQRS integral phi integral PQRS B dot dl will be equal to P to Q B dot dl plus Q to R B dot dl plus R to S B dot dl plus S to P P R dot dl. So this will be equal to 9Q to R B dot dl is equals to S to P B dot dl is equal to 0. So sum of this is equal to 0 itself because it is outside. Okay. Now because QR and PS the field is at the right angle to DL. Okay. So this is we are taking the field as 90 degrees. So 90 degrees equal to 0 degree. And we are taking the field here closed path, in the closed path itself, not in the outside, not in the open path. It is in the closed path itself. So it is not outside, inside itself, but it will be equal to 0. Why it is 0? Because B dot dl cos 90 is equal to 0 itself. Now R to S B dot dl will be equal to 0. B is 0 at point outside the solenoid. Then B dot dl will be equal to P to Q B dot dl. P to Q B dot dl cos theta will be equal to B dot dl equals to dl. Now hence from Ampere law, phi PQRS B dot dl is equal to mu 0 current enclosed by PQRS. Okay. Now number of turns in the unit will be N and the number of turns in the length will be NL. The current in each turn will be equal to I, so that the current enclosed by the loop will be NLI. So the current, total current will be I net I will be equal to NLI. So PQRS B dot DL will be mu 0 NLI. Will be BL is equals to mu 0 NLI. So it will be equal to mu 0 NI. Now from the expression, it is clear that B is independent of the length. B is independent of the length and diameter of the solenoid and is uniformly over the cross section of the solenoid. If a material of beam is mu r, is of permeability mu r is used as a core, and B inside the solenoid mu 0 mu r Ni at point near the end of the closed solenoid will be equal to 1 by 2 mu 0 Ni. From note the formula mu 0 equal to mu 0 Ni is valid only when the length of the solenoid L is much larger in comparison to that of the radius of the radius R, that is L is much greater in comparison to R. So basically here we are considering the path of the PQRS, and PQRS path is equal to 90 degree, and if here it is 90 degree, then cos 90 is equal to 0. Integrating it equal to 0, we will be getting the value of B dot dl. Okay, so by using ampere circuitry law, we will get the value of the net we are going to get the value of B dot dl, and the net current will be NLI, and PQRS B dot dl will be equal to, or B will be equal to mu 0 Ni. So we are taking the value of B is equals to mu 0 Ni, where this particular value is of L is much more greater in comparison to that of the radius of the of this particular solenoid. So it is very well understood by the formula, or by the particular observation of this particular ampere circuitry law, and magnetic field of a solenoid is being expressed here. So I think you have very well gone through this, and we will be moving towards the next topic, which is after this video. So please learn and study hard for your half-yearly exams. Thank you, students.